Hey guys, welcome back to my CCNA 200-301 course. Patrice is here, and in this video I'm gonna show you how you can secure your wireless networks. Are you ready? Let's get started. When you're dealing with wired networks, to prevent unauthorized users to access your network, the only thing you need to do is securing your perimeter and do not let unauthorized people to come to your office and plug in their devices. But when it comes to wireless networks, your data is pretty much in the air. And the only thing that an attacker needs to do to be able to intrude to your network is being in the coverage area of your access points. And from that moment on, you are vulnerable. So securing wireless networks is really an important thing. And you need to make sure that you can and you would secure your wireless networks as much as possible. The first question that we need to answer is what security parameters we need to consider to secure our wireless networks. These items or parameters are applicable to wired networks as well, but our focus at the moment is wireless networks. The first parameter is authentication, which means that you need to get your users or devices to prove their identity, which can be through a pre-shared key, username and password, certificates, etc. The second item is privacy. Privacy simply means that even if your wireless network data can be eavesdropped or captured by some unauthorized people, they cannot interpret it. And that is happening through encryption. And finally, integrity. Integrity means that if point A or device A wants to send something to device B in the wireless network, or even between wireless network and a wired network, that message will not be altered in the middle. And that is happening through message integrity checks in wireless networks. Let's start with first authentication mode or authentication method, which is called open authentication. Open authentication simply means that no authentication. And why do we need it? I'll let you know. Let's first see what would happen in the open authentication, or when you configure your wireless network to open mode, what would happen for authentication. Open authentication simply means that if your device is capable to speak with 802.11 standards, it would be able to connect to a network. So you can see this conversation between the endpoint and wireless authenticator, which could be your wireless access point, wireless controller, etc. So first, the client sends a request to access the network. Then the access point will ask if you're able to talk with 802.11, and the computer says yes. And then, okay, you're free to access the network. As I said, this simply means that no authentication. But where we need it, you probably have been in some places like airports, cafes, or any public areas that provide wireless connectivity for you. And you just search the SSID, and you can see that there is no any lock on that SSID, and you just which means that it is on open authentication method. And when you connect to that one, it will redirect you to a web page, which we call this web authentication. And then they will ask you some question like what is your name, last name, your mobile phone, email address, etc. And as soon as you provide those details, you submit that form, and then they will allow you to connect to your network. So open authentication will be working in these circumstances. Now I want to take you through a bit of history. Web or wired equivalent privacy was the first security method that has been introduced with the original 802.11 IEEE standard. Web is using an algorithm which is called RC4 for encryption. This algorithm supports two different key lengths, 40 bits and 104 bits. In some documents, you may see them as Web and Web 2 or Web 40 and Web 104, which refers to these two different key lengths. Web was okay in the first years of introduction, but after a few years, especially in 2001, some severe vulnerabilities has been detected on web. And in that moment, Wi-Fi Alliance introduced WPA, which I'll be talking about it in the next few slides. And when IEEE ratified WPA in 802.11i, web is being deprecated. This deprecation doesn't mean that web is vanished and you cannot see it in the devices now. The thing is, web is still out there. You can configure your devices, your wireless network with web, which is strictly not recommended. The only situation that you may need to use web is having some old devices that do not support newer versions and you have to use wireless networks and there is no any other choices. But other than that, web is not secure and it is not recommended to be used in wireless networks. Before I dive into a web authentication process, I want to let you know that web is being removed from CCNA 200-301 course exam topics. So you don't need to know for certification purposes about web. But I thought since it is out there, it is better to have it rather than not. How does web work? When the client sends the authentication request or connection request to the access point or wireless LAN controller, wireless LAN controller sends a challenge, or basically it's a text, to the client and asks the client, please encrypt this text or challenge with the pre-shared key that is being configured on you. So a text will be encrypted with the pre-shared key and the encrypted version will be sent back to the access point. And then access point will do the same on its own side. Encrypts the challenge with the encryption key or the web key that has been configured on it and compare these two values. If they are the same, this means that the client uses the same web key that has been configured on the access point. And if not, obviously it cannot connect to the network. The thing is, after this point, when the authentication is completed and the client is connected to the network, all of the data that is going between the client and the access point also will be encrypted with that web key. So web uses that shared key or pre-shared key for both authentication and encryption purposes. As I mentioned before, once the vulnerabilities of web have been identified, Wi-Fi Alliance introduced WPA, which stands for Wi-Fi Protected Access. And you can see the name of the Wi-Fi, which is the registered trademark for Wi-Fi Alliance in the name, which proves it is coming from Wi-Fi Alliance. So far, 3 versions of WPA has been introduced: WPA, WPA2, and WPA3. Obviously, it has become better and better over the years. And WPA uses TKIP, which stands for Temporal Key Integrity Protocol, for both encryption and integrity check. WPA2 uses AES, which stands for Advanced Encryption Standard, which is the latest adopted standard for from US NIST as well at the time of this recording, and uses CBC MAC, which stands for Cipher Blockchaining Message Authentication Code for integrity check. These two together, I mean AES plus CBC MAC, forms CCMP, which stands for Counter CBC MAC Protocol. That counter is coming from AES because it's using AES counter mode encryption. And WPA3 also uses AES for encryption and uses GMAC, which stands for Galois Galois Message Authentication Code. And Galois is the name of the mathematician, French mathematician, who introduced this algorithm that is being using in this protocol. And these two together, AES plus GMAC, forms GCMP, which stands for Galois Counter Mode Protocol. The difference between WPA2 and WPA3 is not only about the integrity protocol they're using. WPA3 has other features as well, naming some SAE, which stands for simultaneous authentications of equals, forward secrecy, and PMF or protected management frames. You can implement WPA in two modes, personal mode and enterprise mode. In personal mode, simply it works like web, process-wise, which means that in a four-way handshake, it does the authentication through a pre-shared key, and also from that moment on, it uses that pre-shared key as the encryption key as well, and encrypts the data via that pre-shared key. But in enterprise mode, we use or combine WPA with 802.1x protocol for the authentication purposes, which I will be talking about it in the next slide. As I mentioned before, in WPA Enterprise, we leverage 802.1x. In 802.1x, we have three main components. The first one is called supplicant, which basically is your endpoint that wants to connect to the network. The second item is called authenticator, which is your network device, which can be your access point, your wireless LAN controller, or in wired network, it can be your switch. And finally, we have our authentication server, which is the database of your identities or your credentials, which can be a server like Cisco ISE or Identity Services Engine. In ISE, you can define users locally in the ICE database, or you can fetch users from external identity servers like Microsoft Active Directory or any directory services server. Anyway, the communication between supplicant and the authenticator is happening through a protocol that is called EAP, or Extensible Authentication Protocol. EAP has different flavors like LEAP, lightweight EAP, or EAP-fast. FAST stands for Flexible Authentication Secure Tunneling, or PEEP, Protected EAP, or EAP or EAP TLS, which stands for Transport Layer Security. Each of these flavors using different mechanisms for securing or providing this communication between supplicant and authenticator. And the communication between authenticator and the authentication server is happening through a protocol like Radius or TACAX+. Alright guys, this was our today's video. In the next video, I'll be talking about routing basics. I wish you enjoyed today's video and see you in the next ones.